Awesome. Cool. And let's begin. Okay. Hey, everybody. Welcome to another session of the Data Lakehouse Hub's Data Lakehouse Lunch series. Again, you can always join the National Lakehouse Link Ups meetup group to always find out about upcoming events. But again, as usual, I'm Alex Merced. I will be your host and speaker this evening. So today we're going to be talking about a guide to architecting an iceberg lakehouse. This is based on a recent article that I wrote that is currently on Medium that kind of just walks through sort of just a mental framework for how to think through architecting an iceberg lakehouse. But before we go there, a few customary announcements. Like first off, who am I? My name is Alex Merced. I'm a senior technical evangelist. I come from a company called Dremio, which we'll talk about momentarily. Gotten to be one of the co-authors in Apache Iceberg, the Definitive Guide. I actually am working on 2 other books from some of the major tech publishers that will be announced over the next several months. I've spoken at a lot of events like Data Council, Data Day Texas, all sorts of different cool things. So I like to talk about technology, and I will go and talk about technology anywhere anyone will have me. But with that, I mentioned that I was one of the co-authors of Apache Iceberg, the Definitive Guide. So for those who do not have a free copy, go get yourself a free copy by scanning this QR. Get a free digital copy. Okay, so again, scan that QR code and you can get yourself a free digital copy. Now, also, we do have a course on getting acquainted with like Iceberg and the Lakehouse. So if you want to get hands-on with Iceberg and get a badge that you can use as a credential, scan this QR code and I'll take you to where you can do that course as well. So that QR code will take you there. And last announcement, again, we have podcasts. So Dremio has podcasts like Gnarly Data Waves, which is a generally like once or twice a month broadcast that we do, having different people from across the industry speak. And then there's my personal podcast, Data Nation, which you can subscribe to on your favorite podcast catcher of choice. You can find all these links over there at alexmerced.com/data, along with all my social links to follow me on Twitter, Blue Sky, you name it, I'm there. But again, this today's presentation is based on this particular article that I have on Medium. Okay, so this article, the 2025 Guide to Architecting an Iceberg Lakehouse. So go check that out on Medium. And yeah, let's get the presentation started. So you'll find, again, more details on that article over there on Medium. But first, let's kind of set the stage. Like, what are the challenges that people are facing with their data architecture nowadays? And part of the reason they're facing these challenges is just because the demands on your data architecture are greater than ever. Okay, basically, you're working with much more data. You need to deliver that data much more faster to many more use cases. So just the scale of the usage of data has grown just as fast as the scale of the actual data. So just being able to process the data isn't enough. You have to it compounds with its use cases. And this creates a lot of different challenges because oftentimes the usage of this data is siloed between different sort of departments or business units within the company. And this creates issues such as excessive replication because basically maybe each business unit is using a different data warehouse. One business unit is using Snowflake, another one's using Redshift, another one's using BigQuery. So then what happens, you end up recreating the same data in many different places because everyone has like their preferred tools. Consistency. Okay, the problem is with everyone replicating the data across all these different tools, over time, the versions of this data become slightly different and inconsistent. So you end up having sort of inconsistent insights across the enterprise that lead to, not ideal insights that can lead to dangerous decision making. So that's a challenge. So not only we don't want so many different copies of the data, which all result, and then we want to make sure the data we do have is consistent, and we want to make sure we're able to access that data quickly. Again, all that stuff that came before affects that because the more times I have to copy the data, that's just one thing that's delaying between me and accessing the data. Okay, having to go clean up and fix inconsistent data, that's another thing that's going to delay time. Also, just the sort of the raw compute power of whatever tool you're using, all these things are going to sort of slow down that time to insight. And all of this adds up the cost because the more compute time you're talking about, more costs. The more replication you're doing, the more storage costs. Cleaning inconsistent data just requires, time of your data engineers, which is a cost that could be, that time could be spent doing something else, whether it's expanding and growing your data architecture versus just maintaining what you have. So we have all these sort of different challenges that need to be addressed. And again, with that growing scale of data and the growing number of use cases of that data, that becomes an issue. Okay, so generally the idea here is you want to solve these challenges, and now you want to architect sort of a new solution in this new paradigm. But before you even explore a new paradigm, you want to understand sort of where you are at currently. You want to do a pre-architecture audit. Say, hey, what is my data architecture currently? And ask yourself questions like, where is my data? Okay, is my data in these data warehouses like Snowflake and BigQuery? Is my data maybe in a database like a Postgres or a SQL Server? Where is my data currently being held? Now, of that data, which data is currently being used the most? Okay, because that's where you're going to end up seeing the most benefit when you start thinking, because you're not going to migrate all your data from one architecture to a new architecture overnight. It's going to be something you do incrementally and progressively. So in that case, you want to think through sort of, hey, which data sets am I going to move? Which data sets are going to have the biggest business value to move? So that way I can schedule that accordingly. Now, which data sets cost the most? Okay, so you may have a data set that maybe isn't as used, but because it's a huge data set, the queries that do go there end up resulting in a lot of cost to maintain. So there may also be a data set that's a nice target to be one of those data sets you migrate earlier on than later. So again, trying to understand the data sets you have can be very valuable in this sort of planning out this migration strategy. Now, which data platforms do you need? Okay, like of the tools that your different teams and different business units are using, which ones are non-negotiable? Okay, are they saying, hey, you know what, if you change your architecture, we still have to be able to use X? Okay, then you're going to want to make sure that whatever formats you adopt can be supported by that tool. Okay, because you may have, one team that really likes BigQuery, and you might go in a direction that says, hey, we can't use BigQuery, and so you're going to want to have that flexibility, or you want to know what is the level of flexibility you need. So these are the questions you ask ahead of time, because you may not need that flexibility. Maybe everyone is using the same tool. In that case, this becomes a lot simpler. What are your SLAs? Like what are sort of like the time to insights that you're trying to reach? Not like ideal world though. Ideal world, everything is absolutely real time, correct? But what is something that will at least meet your current business needs? Okay, does data need to be fresh within a week, within a day, within an hour? What is the exact level of data freshness that is currently needed to hit the certain sort of goals and value propositions that are realistically being asked for? Okay, and sometimes that might require you having to sit down with sort of like a lot of your data users and really kind of pushing on it, being like, do you really need the data within 1 second? What are you trying to achieve? Like, how often is the data changing? Like, really kind of asking those questions to understand sort of not what they want, but what they need. What tools are accessing your data? Again, what are those non-negotiables? What are your regulatory barriers? Because, hey, some tools and platforms may not be usable because of security concerns and things like that. So they're just not going to be on the table. Okay, so you want to know what those requirements are, so that way you don't get too deeply down the road doing a POC with a tool that you're not going to even be able to adopt in the first place. So once you ask those questions, now you can start thinking about, okay, hey, what is this new architecture I'm going to go at? Because now you have the framework of what are my needs to filter out the different options. Now you can sit there and just take a look at all the different choices above to you and say, hey, do these check off the boxes that I've sort of pre-thought through before looking at any of these solutions? Because again, once you start looking at the solutions, if you do that first, then what's going to happen is that you'll start adding needs that you technically probably wouldn't have thought of as a need ahead of time, because of marketing communications that tell you this thing is a need or whatnot. You just kind of want to objectively sort of look, hey, where's my enterprise at? What is its needs? And then look at the tools. Okay, with that filter prepared. Okay. So now, in this case, generally the architecture you're going to move to is going to be some sort of permutation of the Lakehouse, okay? Because essentially, this addresses those specific problems that we discussed at the beginning of this presentation. So let's first discuss what is a Lakehouse. And just to put it pretty simply, it's just the next iteration of what we've been doing this whole time. So traditionally, we put data in databases and data warehouses. And in these databases and data warehouses, these tools abstract a whole bunch of a bunch of stuff away from us. Like we don't have to worry about how the data is stored. How does it recognize which data belongs to what table? How does it know which tables exist, the catalog, and how does it actually process the queries that I send over to the database or data warehouse? Okay, and this makes it really simple. Okay, I can just put my data into the system, whether it's a database for row-based transactional type data or a data warehouse for columnar-based type analytical type queries. I just put the data in there and I can just begin working with the data and it's optimized for the type of work that I'm doing. The problem is each of these systems work differently. The way they store the data is different. All this stuff is different. So they're kind of their own little silos. So when you start having, again, multiple business units, each kind of making their own decisions about which systems they're going to use, what you end up having is, again, the need to replicate the data because each of these systems work differently. So ideally, you would want the data in a place that is sort of abstract or like separated from the system. You want to separate necessarily the storage and maintaining of the actual data from the processing of that data. And that's kind of where we get into with the data lakehouse. So we take what you already have. So most people will have some sort of storage layer called the data lake, where you have this sort of independent storage layer, like a Amazon S3 or Azure ADLS or a self-deployed instance of MinIO, some sort of object storage typically, or Hadoop. And you store all your data as files there. So CSV, JSON, ORC, Avro, Parquet. You store your data as files there, and you can use different tools like Dremio or AWS Athena to query the data that is on that storage. Okay, and this can be a good pattern for a lot of ad hoc queries and things like that. The problem is once you want to start doing much more data warehouse-like workloads that involve a lot of updates and deletes and modeling and certain performance needs to deliver to that very last step, you're going to run into this issue of you don't have things like ACID transactions and other things that data warehouses have that really allow you to sit there and say, hey, you know what? How about I just operate completely on my data lake? And the reason is because we're missing a couple layers. You notice that we don't have the abstraction of, hey, what is a table and how do we track those tables? Those pieces are missing. So we turn a data lake into a data lakehouse by adding back those pieces. Okay, we take the storage layer you already have, we take the processing tools you're already using like Dremio and Athena, and we're going to say, hey, we use a table format like a Iceberg, a Delta, a Hoodie, a Pymon. And then we're going to have some sort of catalog that tracks those tables and then allows those tables to be queried when it's connected to your preferred tool. And now each business unit, so now the actual storage and management of the data is now separated from the client you use to process the data. Okay, so in this case, one department who likes to use Dremio can use Dremio. Another department that likes to use BigQuery can use BigQuery. Another department that uses Snowflake can use Snowflake to run queries on that same data. So you have sort of, again, you now have consistency because you're only working with one copy of the data. You have less replication in that case. And that's going to, again, solve a lot of those cost problems and also helps performance. That's going to be more with just the design, because these table formats are designed to give you enough metadata to be able to scan those tables very efficiently. And then because the storage is using object storage, it can independently be scaled to handle as many transactions as you want, because again, that data is being replicated over how many different instances behind the scenes. It's all being managed by the storage system. So then multiple tools trying to access that same data set can do so without affecting each other's performance. So you're getting this sort of big performance benefit. You're getting this huge reduction in replication and much better improved consistency in this pattern. But of course, you have to implement it. And one of the key table formats, because again, the key focus of the article that I wrote is how do you build an Apache Iceberg lakehouse, is going to be using Apache Iceberg as your table format. And mainly because it's going to probably be the one with the most robust support across the ecosystem. So in that case, when you have many different departments using many different tools, this is going to be sort of the best place to standardize. Okay. And Iceberg, again, is a table format that allows you to store data across different tiers of metadata, such as the metadata file that tracks like the table's partitioning and schema and so forth. Then you have these manifest lists that track a particular version of the table, a snapshot of the table. And what that basically does is says, hey, these groups of files are part of this version of the table. And then those groups of files are referred to as manifests. and each of them has a list of files, and all of this has a much more granular metadata included in it that can be used to determine, hey, which groups of files do I need? Which individual files do I need? So you can skip data files for much more efficient scanning, because you may have a data set of 1,000 Parquet files, but you only really need to scan like 3, depending on the query. So this ends up, again, creating that standardized way of representing your tables. So data sets that are stretched across many different Parquet files can now be treated as a singular unit and interface in the same way you interface with tables in a data warehouse, with all the same ACID guarantees and all that. So this provides, again, all those benefits that we're talking about. But the table format, again, is only one piece of the picture. Again, the data lakehouse is a lot of pieces that you have to kind of decide how. It's like basically, instead of just taking a data warehouse off the shelf, it's like a Build-A-Bear, okay, where you choose the pieces that come together. So let's think of the pieces that make this stuff up. So let's first think about the pieces that make up a data lake house. First is your storage, your data lake. So somewhere you're storing all your data as files. So you need somewhere to store that. You need to have a file format. How is that data being stored? The standard there is going to be Parquet files for analytical queries. Then a table format like Iceberg, so that way you can treat those Parquet files not as a bunch of Parquet files, but as single individual tables. And then you need a catalog that is aware of the different tables on your lake, so that way tools can then interface with that catalog and say, hey, these are the tables that are available. And this would be a tool like Polaris. When you put all 4 of these together, you've basically taken care of sort of the warehousing part of the data warehouse, aka the data lakehouse. Okay, you have this thing that basically operates like a database. I just connect to that lakehouse catalog, and now I can see all my tables, send queries to execute those tables. But then you need a platform to actually operate on that data. Okay, so you have the data lakehouse, which is essentially like the data being stored and tracked in this way. And then you have the platforms that interact with that. Okay, and generally, ideally, you're going to need a few different features in that platform. You're going to need integration. Okay, because all your data is not going to be necessarily an Iceberg. You're always going to have other data in other places, whether because you purchase data from like the AWS marketplace or Snowflake marketplace, or a third-party vendor has given you access to some data in a database that they run. You're going to have this sort of long tail of other data that you want to integrate, and you don't necessarily want to have to do another round of ingestion just for this data. You can work with it directly from where it is. So you want something that can federate queries across multiple sources, okay, in your Lakehouse platform. You want something with a semantic layer, because you want something where you can actually build your data models on, because you're no longer in a data warehouse. So you don't have this ability to create marts and whatnot. Instead, you want something that can simulate that same type of data mart experience, where you can create these logical warehouses for your different sub-businesses in sort of a single place. And you want something that can give you additional acceleration. So typically that would be done through like materialized views and cubes, but you want some sort of acceleration mechanism to accelerate the most business valuable workloads. And a platform that can do all of this for you on top of your data lakehouse data is your data lakehouse platform. So essentially, at the end of the day, whether these are just one platform or multiple platforms, these are the pieces and the roles that they play when you're building that lakehouse. Okay, so again, this could be one platform. This could be multiple platforms that give me these pieces. Again, these pieces are pretty clear what they are. But when you have this, you then have your architect. You have your architecture. And it's just a matter of putting in these pieces and swapping them out when needed. So the end result, what you get is you have a data lake that turns into your data lakehouse, because basically the data on the data lake becomes abstracted into tables and via your table format and catalog. So the table format and catalog takes those files on your data lake and turns them into a data lakehouse. And then your data lakehouse platform will then allow you to consume that data into your notebooks and BI tools. Okay, and then that's sort of like the flow or the pattern. So let's kind of go through these different layers. So you have your data lake, and your data lakes could either be something like a public cloud. So again, think of something like an S3, ADLS, GCP. Could be sort of a hybrid situation where you're on-prem and or on cloud. So you could be using a tool like MinIO, which could deployed in either situation. Vast Data, Pure Storage, NetApp Storage Grid, Nutanix, These are all different storage solutions that can be that can serve that role of your data lake, and they oftentimes come with a lot of other features that they can provide you a much more a bunch of extra sort of data platform like features along with it. For example, like Vast Data has this thing called the Vast Database, where really kind of its storage is really optimized to storing data in a sort of its almost kind of its own table format. But Dremio does have a connector for that, which can be really make for a really very performant on-prem deployment, which is really popular for like AI use cases, stuff like that. Minio has a really kind of cool like replication. NetApp has a really cool tool that allows you to kind of sync what you have on your on-prem storage grid setup and be able to sync it with like a public cloud, so that way assets that do need to be available on a public cloud can be there when you need them, and you can kind of set that up. So all of these platforms have really kind of cool additional features, depending on sort of what your needs are for your particular. And again, which is why kind of going into it, figuring out, hey, what are your needs and what are your wants and all that stuff ahead of time can help you kind of sift through all of this. Then your Lakehouse catalog. So first, let's just talk about sort of like what is a catalog. Okay. Now, again, a catalog allows you to know, specifically in Iceberg, the way a catalog works is it allows your tools, so these are your processing tools, so like a Dremio, a Snowflake, Apache Spark, Apache Flink, allows it to communicate with the catalog, and then the catalog is what tells the tool, hey, these are the tables that are available and where they're located on your data lake. So essentially, it's the tool of discovery for your processing tools. And the way it does it is that every Iceberg table has a file called metadata.json. Every time the table changes, a new metadata.json is created. So in that case, you need to know, which is the right metadata.json, and the catalog is the source of truth for this. So it'll say, hey, right now, this is the most recent metadata.json. Here's the S3 address for that particular table. Go for it. So that's the job of the catalog, to know what the names of the tables are, and to know which name belongs to which metadata.json, and and the correct metadata.json. Now, this can be done in a couple different ways. There is a file system way of doing it, which is generally discouraged, just because there's while it's a very easy to use implementation, it doesn't have a lot of the ideal consistency guarantees and other things that you would necessarily want. And this is what's referred to as the Hadoop catalog. Okay, but it's really the file system catalog. It's using the file system to track these references. So instead of having some sort of third party, like the central catalog that tracks all the tables, every table gets this file called version_hint.txt. And that version_hint.txt tells you where the metadata.json is, and then points to it. Okay. Again, generally, if you're using some sort of tool that's just kind of writing a Iceberg table directly to your storage and not connected to some third-party catalog, this is what you can do. Oh, let me just make sure I put this person in. There we go. Now, as you write it, you can always register the catalog table with a catalog later, so it doesn't have to necessarily be done this way. But that's one way. Now, generally, the ideal way to track your tables is using an actual service. So you want to actually have like a catalog server, some sort of service that's running that actually is like backed by a database that has all those references and sort of organized in a way in one place. So this could be like Dremio catalog. Tabular was a very popular catalog that got bought by Databricks last year. You have Hive, you have Snowflake, which also now has this thing called Open Catalog, which is powered by Apache Polaris, the open source project, AWS Glue, Nessie, all sorts of different options in this catalog space. But essentially what happens now is that instead of you having to look at a file and having to worry about the guarantees of, concurrent file updates on the file system, because that's generally where the problem comes in with the file system approach, a tool like Dremio or Snowflake can just contact this catalog and just say, hey, where is this table? And then go interact with the table. Now, in the past, you had this problem where every catalog had to kind of create their own implementation of how you talk to your different tools. And that got really complicated because in the beginning, it was just Java. Everything was done in Java, so every catalog created their Java class, and it was pretty straightforward. But now you have like Pi Iceberg, you have Rust Iceberg, you have Iceberg Go. You have all these libraries for these different languages for Iceberg. And if we kept that status quo, each catalog would then have to go back and write a Python version to use that catalog, a Rust version library for using that catalog, and a Go library for using that catalog, making using that catalog very difficult across these different paradigms. So, but what happened is that they created something called the Apache Iceberg REST catalog specification. So this isn't a new catalog, but what it does, it creates a standard way for catalogs and processing tools to talk to each other. Okay, by saying, hey, catalogs, most of your operations will be detailed on the server side. Okay, and the client will be kind of a dummy client, so that way all of you guys can use the same client. So that way the code that runs on the tool that you use, whether it's like Dremio, Snowflake, whatnot, can be the same regardless of which catalog you use. Because every server has to implement the same interface, the same the way I always like to think of these interfaces is like a language. If we all speak, X language, then we can all talk to each other. But if everyone spoke a different language, it would be really hard to talk to each other. And then every person would have to like learn 5, 6 different languages. And that, eventually that just doesn't scale. So the idea behind having standard interfaces like the REST catalog specification, it creates a uniform language for the communication of client and server for all catalogs. So now any catalog can work with pretty much any tool, long as that tool is able to talk to the REST catalog specification, and that catalog is also able to talk the REST catalog specification. So generally the takeaway there is that whatever catalog you end up going with, you want to make sure there's some sort of app implementation of the Iceberg REST catalog in that catalog for your lake. And there's a lot of tools that support REST catalog nowadays. So you can see here logos for a lot of our favorite tools. And there's a lot of catalogs that support the REST catalog. So here's some of the main ones: Nessie, Gravitino, Unity, Polaris, all support REST catalog. Now, again, not all of them support it in the same way, because the REST catalog at the end of the day is a REST API spec. So not every catalog implements every endpoint in the spec. So for example, Unity doesn't support the write parts, because the way Unity works is that it's not about writing to Iceberg, it's about writing to Delta and then mirroring to Iceberg. So it allows you to create mirror metadata and then be able to read that externally. Okay, so you can still read it as Iceberg with some limitations, but at least it gives you that dual access. And then while the other three, Nessie, Gravitino, and Polaris catalog should all have are all native Iceberg catalogs and allow read and write. And then your data lakehouse platform. So we mentioned the kind of things you want. You want a platform that can, federate queries. You want a platform that has a built-in semantic layer, and a platform that can accelerate your queries. So that way, you have one place that kind of takes all this sort of, basically this wrapper that takes all these sort of disparate pieces and still makes it feel like a unified, cohesive warehouse system. Okay, and a really good platform for that is, of course, Dremio. Okay, because Dremio really does have all of that stuff under one hood. So instead of having to get like a different semantic layer provider and a different thing that can federate a different engine that can federate queries, and then having to get like third-party libraries or third-party tools to accelerate your queries or build out your own materialized views and cubes and things like that, Dremio can kind of take care of all this for you, because it has unified analytics. And again, here you see the picture where basically here you're connecting all your data, so you can connect your object storage, aka your lakehouse. Okay, and you can connect your other sources. So that's where the federated queries comes in. Okay, you're able to connect your data everywhere. So now all that third-party data you're working with, you don't have to add those additional ETL jobs for that, because you can just work with it where it is, alongside your Iceberg data that you've been landing in your lakehouse. Okay, along with a semantic layer that allows you to build your data model, so you can actually build sort of those virtual data marts for your different business units right there directly from Dremio, and then make sure you govern the access to those marts to make sure that only the right users have access to them. So it kind of gives you that whole interface all in one place, along with the ability to manage wikis, so you can actually write documentation for your data sets, tag them for search. And this all actually works really well with like dbt. So technically you can use dbt to model all your data across all your data sources in one place, and have, since if you're using dbt, that's all code. So that gets checked in the Git. So now you have the benefit of like having like Git commits to be able to audit the changes to your modeling over time, and be able to track, hey, what models ran, or use GitHub Actions to trigger changes. If you ever actually want to see how you do all that, I just released a course over there on university.dremio.com which also should be on LinkedIn soon, which is a data ops for Iceberg, where I kind of go over using like dbt and GitHub Actions and triggering like tests and stuff like that. It's pretty cool. But the Dremio query engine is also really fast. So again, it allows you to run queries across all these different sources. So that way you can create the sort of unified view across all your data, create that semantic layer. And Dremio has a feature called reflections that basically eliminates the need for you to do a lot of that manual acceleration. So instead of you having to create and maintain a bunch of materialized views and cubes, and then having to educate your analysts on all that these cubes and materialized views exist, so that way they can adjust their queries, Dremio has a feature called reflections that you can just turn on the data sets you want to accelerate, and you're good. Okay, so you don't have to maintain anything. Dremio does all the maintenance for you of the acceleration, and the analyst doesn't have to really be aware of it. Dremio will substitute those accelerated will substitute the cache when it makes sense. So in that case, the queries that the analyst wrote don't have to change. And then oftentimes what you'll see is that people who have you might reflect one data source, and it might not only accelerate the queries that you're targeting, but accelerate other queries as well. So you end up getting the sort of overflow benefit, depending on sort of what your reflection strategy is. And that's even easier to use now because Dremio has added a reflection recommender. So instead of you having to kind of reason which data sets should be reflected, Dremio can actually take a look at your cluster's query activity, determine sort of these are the reflections that you want. Okay. And Lakehouse management, basically Dremio can help manage your Lakehouse. Okay, and if anyone's wondering, I will post a recording of this on the Data Lakehouse Hub YouTube channel. So just look up the Data Lakehouse Hub on YouTube, and you'll be able to find the recording of this that I'll post right after this is done. But Lakehouse management, the idea here is that Dremio can actually manage your Lakehouse. Because one of the problems with the Lakehouse is that the data warehouse, there's just other things you have to think about. Like how do you manage the physical data under the hood and make sure that it's optimized for querying? How do I clean up data that I don't need for like historical versions I don't need anymore? A lot of that stuff was just kind of abstracted and automated away from you. With Dremio, you get that same sort of experience with your data lakehouse. Dremio can then provide you a catalog, and then the tables that are tracked by that catalog can then have that automatic maintenance kind of happen. So that way it just works. Your tables are kind of constantly being optimized. Excess data is being cleaned out. So that way you're not having, this excess storage usage that you don't need, and two, your data files are always kind of written in the ways they need to be performant. But one of the most unique things about this whole platform is that it is hybrid. Okay, unlike a lot of platforms that are cloud only, which basically locks out a lot of people who still have on-prem or are required to have on-prem footprints of their data. With Dremio, you can deploy Dremio in the cloud, you can deploy Dremio on-prem, and then either way, you can connect the data sources wherever you deploy. You can connect to cloud and on-prem data sources. So this allows you to kind of really build a sort of unified layer on top of your lake where you can manage everything in one place the way you've been used to with the data warehouse, but you still have your data accessible by different tools. Because even though Dremio is one way to query your data, all those data sets get tracked by the catalog, and other people who use other tools, let's say Spark, they can connect to that catalog and use Spark instead against Dremio catalog. So you get that the flexibility, but you still also get that nice, easy wrapper. And one way to really see how all of this looks like when it's all implemented and put into place is to try out one of these tutorials. These tutorials will kind of walk you through building a lakehouse on your laptop, all the way from ingestion to building a DI dashboard. So this one will just kind of create the lakehouse on your laptop pretty basically. These three will walk you through an end-to-end exercise where you ingest data and then land it and then build a BI dashboard. But these will kind of allow you to kind of see sort of like the whole nature from end to end. So that's there. Again, go check out the article on Medium, the 2025 Guide to Architecting an Iceberg Lakehouse. Subscribe to Gnarly Dataways on iTunes, Spotify, or YouTube by subscribing to the Dremio YouTube channel. And of course, join the Data Lakehouse Hub community. Okay, so again, this is all put on by the Data Lakehouse Hub, datalakehoushub.com. You can join the Data Lakehouse Lunch series. But again, a lot of that stuff you can communicate with other people who've joined the Data Lakehouse community and join the community over there at the Data Lakehouse Hub by scanning this QR code, or just heading over to the datalakehoushub.com. And you can never, if you want to know all the events that I'm going to be personally speaking at, I have this calendar where I'm constantly listing all the events that I'm speaking at. So that is there. And that brings us to the end of our presentation. So at this point, I'm going to open it up to questions. So let me take a look. So if anyone has any questions, feel free to come off mute and ask away. And then absent no questions, give it another minute. Great, go for it.
So you spoke a little bit about migrating from like BigQuery or a data warehouse to Dremio. What would that actually look like? Like you said, I agree that the best way to do is to identify the most important, heavily used data first and move it over in stages. That is great advice. So thanks for giving us that. But what, like in the weeds, like what does it look like? Can you pull back the curtain on that a bit?
Well, it depends. So when you're migrating to the Lakehouse, it depends. So again, when I say migrating to the Lakehouse, doesn't necessarily mean migrating to Dremio. I do think Dremio makes the migration story a lot easier, and I'll talk about that in a second. But it depends on sort of how you're doing it. This is where having like the federation, the semantic layer, and all that stuff sort of under one hood makes that migration story really easy. Because, for example, let's pretend that you're using Snowflake and you want to start moving up more of your work over to the Lakehouse. Well, what you can do is Dremio can connect to Snowflake. So essentially, you can see all your Snowflake tables right there in Dremio and begin doing, instead of modeling your marts in Snowflake, you use Dremio semantic layer to model your different business units. And usually what you do is that you create 3 layers. In the same way you do like bronze, silver, gold. There might be different names for it, but the idea is that raw bronze layer would be a bunch of views that are just like select star. So like select star for every table. And then you model all your versions of your data on top of that. Now the beauty of that is, then what happens, you also connect your data lakehouse. So you might connect your, let's say a Nessie catalog or a Polaris catalog to Dremio. And then as you move tables, so I might move table X from a Snowflake table to an Iceberg table, I can now go back into Dremio and then just update the raw view on that table and change it from select star from snowflake.sales to select star from Nessie.sales. And then now I don't have to redo my entire modeling. My modeling stays intact. All people's dashboards stay intact. Nothing has to really change because all you have to really do is just update the queries that are underlying the views in the Dremio semantic layer, because Dremio can connect to both data sets. So first thing you would do is just first set up Dremio on top of your existing data locations and then update your semantic layer as data sets move over from one location to the next.
Thank you. And then just one quick follow-up, if that's okay.
Yeah, go for it.
So great. And then so in that first stage of that, where the select star from Snowflake, for example, and that's in your, we'll call it bronze level of your medallion schema with, medallion transformations with, those, even in that picture, then is what's happening at the silver and gold levels, Iceberg stuff?
Well, it depends. Again, depends on how you do it. Generally, what you're doing specifically with Dremio, all of that's going to be SQL views. So all of that's going to be logical. So basically, so when I move that Snowflake table over to an Iceberg table on the lake, that's when the table becomes Iceberg. And then all the logic for how the data is transforming is in the SQL and the views. And then what you do is that, let's say, so instead of having to create like in a traditional bronze, silver, gold, where you're creating a copy of the table on each layer, what you're doing is you're just creating a logical view of the data in each layer. So you're applying the same like transformations, but you're doing it logically instead of physically. And then so what's going to happen is that there's going to be certain data sets you're going to be like, you know what, I want that to be a little faster instead of having to recompute the whole thing every time. And that's where you turn on reflections. So what you would do is usually in your gold layer, you would figure out, hey, what are your most important gold pieces that need acceleration? And you turn on reflections on those. And then Dremio under the hood is making an Iceberg cache against those gold views on your lake and substituting it transparently. So at the end of the day, your end user doesn't know if there's a reflection or not a reflection on it. It's just going to run the query against the same view. But if there's a reflection, it's going to be faster.
And those reflections, those could work regardless of whether the raw data is that Snowflake select star or Iceberg?
Correct. Now, ideally, you're eventually going to want to move as much to Iceberg as possible because reflections are even more enhanced when you're working with Iceberg data. So once the underlying like the raw layer is an iceberg, then what happens is that all those reflections can then be refreshed whenever the underlying tables change, like automatically. Like generally by default, what you do is you set a schedule. So you'd say, hey, like I want this reflection to refresh like once an hour, once a day, once a week. Or you can manually trigger it, and then you'd have to create like your own script to kind of determine when to manually trigger it. So, you know, there's there depending on how often the table changes, that, you know, if you have a table that changes like every minute, that might be very difficult. And then typically the reflections are recomputations. So in that case, you know, rebuilding the entire reflection every, you know, let's say every few minutes wouldn't really be a viable thing. This is where having your data in Iceberg really pays off, because now Dremio will know to update the reflection the minute the table changes. Like it just notices the change, because Dremio can monitor Iceberg metadata very intelligently. But then two, it can do it incrementally. Because of the Iceberg metadata, it can tell sort of, hey, what is the new data? And instead of having to recalculate the whole thing, it can just add the additional data. It can just access sort of the new data and then figure out, hey, and then apply the logical views on top of that and rebuild, update the reflection.
Thank you.
Yeah, so you can work with your data anywhere and basically get the data lakehouse feel right away. That's the beauty of Dremio, that you can just put your data on whatever your data is now, you put Dremio on top of it. You can use that semantic layer, use reflections as if you were, and then get the experience as if you already had fully moved to Iceberg on day one. But that story still does get better once you do natively move into Iceberg, because then the reflection story ends up becoming even better and also even cheaper. So like the cost savings you'll get up front is there, but you'll get additional cost savings as you move to Iceberg as well, and performance benefits, and also just nice to have all your data in one place for the most part. And then again, people who do want to run queries in Snowflake still can, because Snowflake can connect to Iceberg catalogs. BigQuery can connect to Iceberg catalogs, and Spark, etc. Most tools can connect to Iceberg catalogs, so they can connect to that Dremio catalog, which supports the REST spec. So in that case, for those teams that may want to operate outside of Dremio, they can, but you get that nice unified experience when you have the option to have that unified experience. So you have that flexibility design to use it the way you need to use it. Cool. I'll leave it open for another 10 seconds. No problem.
Thank you.
No problem. Any other questions? Going once, going twice. And cool. I guess that's going to be all for today. Again, there'll be more Data Lakehouse lunches coming up, so you can always find that over there on the Meetup group or in the Luma page. Always just head over to datalakehoushub.com to find that listing. And I'll be posting this on the Data Lakehouse Hub YouTube channel shortly, so keep an eye out for that. If you haven't subscribed to that, make sure you do. And with that, have a great day and enjoy. I'll see you all later.
Thank you.
Thank you.